It's the end of the third week of March 2025. Here's the science and space headlines from the week that was. Kanyini phones home, shows us the awesome power of its camera and telemetry. Scientists investigated the state of Mars's core. And a dirtier space station could be key to healthier astronauts, new counterintuitive research suggests.
21 years online. From Star Trek to science and space. And we're not stopping. This is Talkin' Science.
Australia's first state government-funded satellite, Kanyini, has delivered its first images from space, marking a significant milestone for the space mission. A number of preliminary images have been collected during Kanyini's on-orbit commissioning phase, demonstrating the incredible depth of data the satellite will be able to provide once fully operational. The first processed images, released a couple of weeks ago, capture high-resolution views of South Australian regions, including Kangaroo Island, York Peninsula and Adelaide. The vast amount of data, about a gigabyte, behind each image allows them to be processed to reveal infrared details ordinarily invisible to the human eye. That can be used in monitoring crop health, vegetation density, and changes in inland and coastal water conditions.
Well, Myriota's is quite a unique capability. It captures very small volumes of data, but super cheap, which is quite important for farmers and other organisations that don't have big budgets. And the sort of information we capture can actually supplement our visual work. So looking at groundwater levels, various parameters in the crops and things like that, we can actually beam up and integrate that with our research with the visual information. So it's actually quite unique. I think one of their initial trials, just showing how versatile it was, they actually measured tank levels on tanks out in cattle stations and sheep stations. These are massive. These stations are massive, and typically they need to go out on their motorbikes or drive out there regularly to check that these tanks are working properly, because otherwise obviously it could be detrimental for their sheep and cattle. And now at a really low cost, the farmer can sit there in the pub with his app, checking all the tank levels. If he's got one problem, he just needs to go up to one tank. And that's the big, I think, value of that is the low cost.
Since it was launched aboard Transporter 11 last August, the team has been working through commissioning of the satellite's systems, confirming that the solar panels and batteries are functional and X-band radio communications are all operational. The Kanyini mission is Australia's first state-owned satellite and is a joint initiative between the South Australian Government, SmartSat CRC, Innovore Technologies and Myrioта. Once fully operational, Kanyini will deliver critical space data to support future research projects by government and research institutions, particularly in the areas of sustainability and climate impacts. International scientists, including an Australian, say they found evidence of the highest energy neutrino detected to date. The result suggests the particle came from beyond our Milky Way galaxy, although its precise origin remains mysterious, they say. Neutrinos are tiny particles smaller than an atom. They rarely interact with anything else, earning them the nickname ghost particles and making them hard to detect. However, spotting them is possible using detectors made up of thousands of highly sensitive cameras embedded within large bodies of ice or water. The Cubic Kilometre Neutrino Telescope, or KM3 has two detectors searching for signals at the bottom of the Mediterranean Sea, which is where researchers detected a signal from high-energy muon, another type of particle that's generated by a neutrino. The muon had an energy of around 120 peta-electron volts, they say, suggesting its neutrino had an even higher energy of around 220 PeV. The position and orientation of the muon suggest its neutrino came from space, the scientists say, and that they've identified 12 active galaxies from which it may have originated. However, none were confirmed as the source at the time of recording. which remains a mystery for now. Future observations will focus on detecting more such events to build a clearer picture of their origins and the astrophysical processes behind them. This breakthrough reinforces Western Sydney University's role at the forefront of cutting-edge space research and highlights the growing potential of neutrino astronomy. Scientists have successfully used lasers to identify microbe fossils in rocks from Earth, which are like the rocks found on Mars, opening up the possibility of searching for fossils on the red planet. Billions of years ago, the water of Mars dried up. Gypsum and other sulfates formed when those pools evaporated, leaving behind minerals that precipitated out of the water and potentially fossilizing any organic life left behind. This means that if microbes such as bacteria lived there, traces of their presence could be preserved as fossils. But to identify these microbial fossils, we first need to prove we can identify similar fossils in places where we know such microbes existed, such as Mediterranean gypsum formations that developed during the Messinian salinity crisis, the event that occurred when the Mediterranean Sea was cut off from the Atlantic Ocean, leading to rapid evaporation, causing the sea to become hypersaline and developing thick layers of evaporates, including gypsum. The scientists selected an instrument that could be used on a spaceflight, a miniature laser-powered mass spectrometer, which can analyze the chemical composition of a sample in detail as fine as a micrometer. Using strict criteria, they were able to identify and distinguish between carbonaceous material, the elements of life, and minerals like clay and dolomite. Data from NASA's InSight mission suggests Mars has a liquid core similar to Earth's, but European scientists say the core may be solid, at least below a certain temperature. Lianji Main and colleagues conducted high-pressure temperature laboratory experiments to determine the crystal structure and density of the iron sulfide phase in Mars's core. The authors suggest that should temperatures at the centre of Mars fall below approximately 1960 Kelvin, which is within the estimated range for this area, the iron sulfide phase could begin to crystallize and form a solid inner core. Further geophysical measurements would be needed to confirm the actual presence of a solid Martian inner core. However, the work presented in this study supports the potential for a solid inner Martian core today, or in the near future, once Mars has undergone further cooling. Similar to Earth, the core of Mars is expected to be dominantly composed of molten iron metal. However, it is lower in density, indicating that the Martian core must contain a high abundance of additional lighter elements, such as sulfur. Astronauts often experience immune dysfunction, skin rashes, and other inflammatory conditions while travelling in space, and international researchers believe these issues are likely due to the overly sterile nature of the International Space Station. The team believes that the introduction of a higher diversity of microbes onto the station would, counterintuitively, improve the health of the people living and working on the station. To work this out, the researchers got the astronauts on the ISS to collect over 800 samples from across the station and bring them back to Earth. The team then identified which bacterial species and chemicals were present and attempted to work out how the two were interacting. There were far fewer free-living microbes on the station, and the intentional introduction of them could help improve the astronauts' health without sacrificing hygiene. The team found that overall, human skin was the main source of microbes throughout the ISS. Chemicals from cleaning products and disinfectants were present ubiquitously throughout the station, and different modules hosted different microbial communities and chemical signatures, and these differences were determined by the module's use. For example, dining and food preparation areas contained more food-associated microbes, whereas the space toilet contained more urine and fecal-associated microbes and metabolites. When they compared the ISS to different human-built environments on Earth, the researchers found that the ISS microbial communities were less diverse and were more similar to samples from industrialized, isolated environments such as hospitals and closed habitats and homes in urbanized areas. In the future, the researchers hope to refine their analyses to be able to detect potentially pathogenic microbes and signals of human health from environmental metabolites. They say that these methods could also help improve the health of people working and living in similarly sterile environments on Earth, especially as Artemis kicks off and we head to the Moon and Mars. Well, that's the week in science and space news from Australia's Trekzone Media. Keep up to date with our daily science and space stories with an Aussie flair across our social media. If you're in Australia and need a production company, for a live stream or corporate presentation, hire us at trekzone.media. Become a member of our YouTube channel to get the latest behind the scenes and early access to the podcasts when we can. The trek.zone/support for now. And as always, I'm Matt Miller. This is Talking Science.